Welcome to Study Loop.
In this problem, we are looking at the dissociation of solid calcium sulfate into aqueous calcium and sulfate ions. We are given the equilibrium constant Kc and the volume of the container. The first thing we are asked to compute is the equilibrium concentration, assuming that we're at saturation. To do this, let's take a look at the equilibrium expression first. Kc, it's products over reactants, so it's going to be calcium 2 plus times sulfate, and there is no denominator because the calcium sulfate is a solid, and so it does not go into the expression. Since we're starting from pure calcium sulfate, the concentrations of the products will be equal to each other. So we're going to plug in for Kc, 2.4 times 10 to the minus 5, and that's going to equal x squared, because we are saturated from our solids, so when we dissociate, we form equal amounts of both the calcium and the sulfate. We can take the square root of this number to find that our equilibrium concentration is 0.0049 molar. Now we're asked to compute the mass that's needed to achieve this. All the coefficients in the equation up here are 1, so if we want to form 0.0049 molar of each of these components, that's how much we would need to start with our calcium sulfate. So we need 0.0049 moles of calcium sulfate per liter. To clear out the liters, let's multiply by the volume of the solution, which is 1.4 liters. And now we'll use the molar mass of calcium sulfate, which you can find online or in your textbook, is 136.14 grams. You can do that math and come up with an answer of 0.93 grams.